Hi, welcome to math. I have a little video here for anybody who would like just a little bit of a kind of shortcut for expanding binomials. So I made this video specifically for my calculus students, but anybody could really use this because this is not calculus specific material. So the first thing you'll see on the board here um, is I have this funny triangle, and we're going to talk about that in just a second. But remember, a binomial is like x plus 3, and I have it here raised to the fourth power. And so what we're going to do is we're going to get it all expanded. We're going to multiply it all out. But it sure would be nice if we didn't have to go through and FOIL this about 3 or 4 times. So that's where this triangle is going to come into play. Now let's talk about how we make the triangle. The triangle starts with ones. You get a 1, and then underneath it you get 2 ones. And then always down the sides of the triangle you get 1. But each number that's inside is the sum of the 2 numbers that are up above it. So right here, 1 and 1 make that 2 in the middle. And then when you come down to the next row, you get another 1 to start the row, but then 1 plus 2 is 3, and 2 plus 1 is 3, and then a 1 to end the row. And this last row that I wrote, you start with a 1, 1 plus 3 is 4, 3 and 3 make 6, 3 and 1 make 4, and then a 1 to end the row. You can keep this triangle going for as long as you want, and this is actually called Pascal's triangle. So we have this triangle, and why is it useful? Well, it turns out that if we pick the right row, we get basically coefficients of terms in a binomial sequence. So, or binomial that needs to be expanded. So case in point, I have x plus 3 to the fourth. So I select the fourth real row of the triangle. The first top number doesn't really count. So this is first, second, third, fourth. And very conveniently, 1, 2, 3, 4. If you look down that inside diagonal, you can see which row you're on. So if you want the fourth power, you go to where you have a 4, right here at the beginning. And so now all I'm going to do is I'm going to use these as multipliers for each term. Okay, you can see I have a 1, a 4, a 6, a 4, and a 1. Right, just like my numbers across the bottom. And then for the 4 and 3 that I still have to work with, basically I start with the power for x, so I have fourth power, and then each term the power goes down by 1. So I have fourth, third, second, first, and then 0 power. And then for the second half of it, that 3, we go the other direction. We start with 0 and count our way up. 0, 1, 2, 3, and 4. And so what we get is we use these numbers as these extra coefficients here to multiply by, and we use the 2 things on the inside with powers that go in opposite directions. Right? The first one has power that goes down. The second piece has powers that go up, in this case from 4 down to 0 and 0 up to 4. Clean up your mess, and you have your expanded polynomial. So when we do that, anything to the 0 power is 1, so this is just 1 times 1, so x to the fourth. 3 to the first is 3, 4 times 3 is 12, x cubed. 3 squared is 9, 6 times 9 is 54, x squared. 3 to the third is 27, times 4 is 108, single x, and then finally 3 to the fourth is 81, and again anything to the 0 power is just 1, so this last term is just 81. And there you go, that's expanding binomials. Now you can do this if you have a minus sign, but if you have a minus sign, just make sure that if this was a minus 3, that all of these would be negative 3s, and then you'd have to be really careful with the powers, because even powers would turn that negative into a positive, and odd powers would keep it as a negative. So very fun. Anyway, there you go. That's expanding binomials. Hopefully you find that helpful.